So let's get started. My name's Lance Finney. I'm a software developer with a company called Inficon, and I am a Google developer expert in the Angular space. Don't worry, this isn't an Angular talk, although I use a couple Angular examples near the end because that's what I know. And we are going to talk about comparing promises, observables, and signals. So my too long didn't read summary. There are now 3 types of reactive primitives in JavaScript. Promises are the simplest and the oldest. They give us single value asynchronous reactivity. Observables are more involved. They are also with asynchronous reactivity, but they give us 0 to many values over time. And they provide many powerful operators, but they're sometimes overkill when all you need is a promise. The new kid on the block is signals, which gives us synchronous reactivity and solves a completely different problem, specifically around state management. So why do we need to deal with this at all? It's because asynchronous programming is hard. When we first learned to program, whether it was in 3rd grade, moving a turtle around, or in college, or whatever, we probably learned with something like this, where we make a call to A, and take that result and pass it into B, where we make another call, and take that result and pass it into C, and take that result and pass it into D, and take that result and do a final something with it. And we know the order of operations, A, then B, then C, then D, then the console log, and it's easy and it's done, and that's not actually representing the real world. The real world has a lot of asynchronous data sources, and that's what we need to deal with. Whether it's HTTP, we're making a call to the backend, and who knows how long our network lag is. Or a WebSocket, where we have a persistent connection so that we know every time the stock price of something has updated, we get a push from the server. Or disk access, we're getting a file from the machine, and who knows how long it's going to take to load that file. Or user input, who knows when, or even if the user is going to type something on the screen, or move a mouse, or many other things. With all of these, something happens, and we don't know if or when it happens, but we need to respond to it. And that is a lot more complicated than A, then B, then C, then D. All of those approaches had different APIs as they initially evolved, and so you'd have to learn the quirks, but most of them had something along the lines of a callback, at least in JavaScript, because JavaScript is single-threaded. So the way that we could handle this usually was something like this, where when we make our call to A, we pass in a function. A can't give us the result immediately, and we can't wait on it in a single-threaded environment, really. So we give us this function, and when A is done, whenever it's done, whatever it's doing, it will execute the function that we gave it. So we can get the result from A and log it or do whatever we want with it. And this works really well on the small scale. Doesn't work so well on the larger scale. Now we're going to make our call to A, and we have to wait for the result and pass it into B, and then we have to wait for that result, and we end up with this callback inside callback inside callback, and that ends up getting called the pyramid of doom. It's hard to think about, it's hard to reason about, it's hard to write, it's sometimes just hard to fit it on your screen. So, are there better ways? Yeah. And the first better way that really took hold was promises. Promises work by separating the call from the callback. They still have a callback, but instead of passing that callback directly into the function, that function is going to give us a promise that takes the callback. And that's a small difference, but it's important because it makes our life a lot easier. Now, instead of having these nested calls with a pyramid of doom, we have chained calls. We make our call to A, and it gives us a promise, and we sit there and we wait on the promise, and when that promise is resolved, it gives us that value that we can then pass into B. And B will return a promise, And then we can wait on that. And it's a chain, and it's just so much less code and so much easier to read. And we could take a subset of this and extract it to a function and return a promise, and it's easy to deal with. It's so much easier to refactor this than the Pyramid of Doom. But we can do better. There's now some syntactic sugar called async await, where if you slap the word async at the beginning of your function, then you can put the word await in front of all of the calls that return a promise, and it will unwrap the promise for you. It will do the then for you. And so you end up with code that looks a lot like that first line of code that you were able to write when you were in 3rd grade and moving the turtle around. It's not exactly as easy, but it's a lot easier for most of us to think about. Now, this code is not exactly like the code on the previous slide, because anytime you use async await, you have to return a promise. So even though this function doesn't explicitly return anything, it still returns a promise. The previous one didn't. And this can be annoying, but it's actually better because it's more honest. This function has an asynchronous aspect. It's waiting on something. And now the caller is forced to know it, and that's a good thing. We can also handle errors. So if our call to A succeeds, great, then we'll deal with the result. But if it fails for whatever reason, bad URL, network down, whatever, then it'll drop down to the catch. And these can be chained on each other, and then we can also put on a finally, so if it succeeds or fails, we can do whatever cleanup we want to do. And handling catching finally, that might sound a lot like our old approaches, our old friends of try catch finally, and that's what async await will give us. If we put the async at the top of the function and then await on our promise-based functions, then we can wrap it all in try catch finally. And this is a construct that we've had for much longer than we've had promises, and it just feels like code that most of us know how to deal with. The main niche for promises these days is HTTP calls with the fetch API. And with fetch, you can pass it in a URL, in this case, something from the Star Wars API, and then, however long it takes for that value to come back, we can deal with it. And we can get that response and pull the JSON out, and then dig into the JSON results and the properties on it, and then log it out, and we can see all the information we want to know about R2D2. Note, response.json and json.result.properties don't return promises, but we still can chain on them. Anytime you return anything from a then, it's automatically wrapped in a promise, which might be annoying, but it also gives us a consistent API. We can just chain these thens, and it's great. We can also sometimes cancel promises. Fetch gives us that through a friend called abort controller. So what we can do is create an abort controller and then pass it in as an optional signal. Now note, English apparently has only 3 words for programming. Signal is one of those, and I'm going to be talking about signals at the end of the talk for about 20 minutes. Completely different use of that word, so don't be confused by that. But we can pass in this signal from the controller, and then in a timeout, 10 milliseconds later, we can abort it just because. And that 10 milliseconds is quicker than the Star Wars API, so it'll drop down to the catch block, and we can log it out on a console error with our just because. So we get cancellation with fetch. So the summary for promises: asynchronous reactive programming, very standardized. It's in all modern browsers. It's cancelable sometimes with abort controller, and it's ideal for HTTP because there's a single call and response. But what if we need more than one value? That's where we get observables. I like this matrix. It helps me think about observables. There's a lot of analogies that we use when we talk about observables. And this one, it's helpful to think of it kind of like an array. When we have a single value in space or in memory, we use a variable. When we have multiple values in space or memory, we use an array. When we have a single value over time, we can use a promise. And when we have multiple values over time, we can use an observable. It's not a perfect analogy, no analogy is, but we'll see later that there are times where the structure around using observables is a lot like arrays, and it helps me to have this analogy. What's the niche for observables? It's pretty big. WebSockets. As I said, you make a call to the back end and get it whenever. User input, who knows when or if the user is going to type. Mouse motion, who knows when they're going to move it. Any event, listening to a button click. Any stream, any combination of these events or stream. It's a big niche. The history of observables is that they were invented in Microsoft about 15 years ago as part of .NET. It's a combination of the observer and iterator gang of four patterns. And it was useful enough that it quickly spread to other ecosystems. You can see a list of them on the right here. The important one for us is the second one, RxJS. And RxJS was out there. It didn't get a whole lot of attention until Angular adopted it when Angular became Angular 2. And so it really grew with its influence at that point. And now RxJS, reactive extensions for JavaScript, is the de facto standard for observables, but it's not a real standard. And a real standard is on the way. WICG is working on it, and it actually has live native observables for us that are available, last I looked, only in Chrome. And maybe that's good enough for your team. It's not for mine. We have to support other browsers, so I'm not using native observables yet, but I'll talk about them a little bit. Mostly I'll focus on RxJS. All right, so with that hand-waving aside, what does it look like to use an observable? Let's start with how do you create an observable? And there are many ways to create observables. I'm only going to show a few ways to do a lot of these things. I have links at the bottom in the QR codes for a lot of these if you want to get more details and see more options. But the easiest way I know of to create an observable is of. So I can get of from RxJS and wrap anything in an of, and now I have an observable that contains that value. When you have an observable, the way you make use of it is calling subscribe. It's kind of like promises then. And you give it a callback, in this case, console log. So I'll create an observable that wraps hello. I subscribe to it with console log, and you can see we immediately get hello on the screen. And this is a really roundabout way of just doing a console log. You can also see there's a console log finish that comes out after, and that shows us that we're dealing with something that is a single value, and it gets executed so quickly. It's synchronous. So why bother having a single value synchronous thing in observables, which is all about zero to many values asynchronous? This is really useful in testing. You need to write a test for something that takes an observable. Instead of creating something complicated, just wrap something in an of, and you give it to your system. You're ready to go. A more realistic example is interval, because now we're dealing with multiple values and we're dealing with time. So again, I can get interval from RxJS. I can define it as an interval of 1,000 milliseconds. And what this means is after 1,000 milliseconds, after 1 second, we'll get a 0, and a second later a 1. And a second later, a 2, a 3, 4, 5, 6, on until the eventual heat death of the universe, or I close my laptop, whichever is first. And you can see, all right, we also subscribe to this in console login. That's the same as before. But there's an interesting difference that console log finished is after this on the code, but it's before it in the console. This is the asynchronous nature. We execute that console log finish synchronously. It's done like that. But we have to wait a second before anything gets emitted from our interval. And so we now are dealing with time. We are dealing with things that happen at some future point. We have a consistent API with the callback to be able to deal with it. We can also capture any event. So I can grab from event from RxJS and wrap that around a button that we get from our document and say, I want to handle the click event, So now, anytime I click on that button, I'm going to get a console log with the information about that click. Is the control key depressed? Things like that. And there's a lot more things you can do with that. Again, documentation at the bottom. Once you have some observables, you can combine them. This is one of many join operators. The simple one, merge. So I'm going to start with single, which is just any synchronous value of hello, and the numbers from an interval, and a click event. And I can merge them together into a single stream that will immediately emit hello, and after a second, 0, another second, 1, 2, 3, etc. And any time interspersed in there, when I click on the button, those will be produced. Is this particular combination of streams useful? Probably not. But doing stuff like this by joining streams together is extremely useful. What if we have one stream that gives us an ID and another stream that gives us the list of things, and they're coming from completely different servers? I can combine them and then figure out which element to grab using that ID. A lot of power by being able to combine these things. Also, these things all would have had different APIs natively. Now they're all wrapped up in a single stream, and I can just handle them one way. I don't have to remember the quirks of a bunch of different APIs. Like promises, observables are cancelable, but it's built in, and it's actually really important to do. When I made the joke earlier that that interval would last until the heat death of the universe, it won't. I'll close the computer before then, or this container will die or whatever. But if you leave a subscription open, even if you don't care about it anymore, it's still open. It will live. It has its own life cycle. And making subscriptions manually is a great way to create memory leaks. So when you manually subscribe to an observable, you have to remember to manually unsubscribe. And there are several ways to do it. The basic way is what I show here, where when you subscribe, it returns a subscription object. And you can see at the bottom, after 2.5 seconds, 2,500 milliseconds, I'm going to call unsubscribe on that subscription. So what happens here is we subscribe. After 1 second, we get the 0. After 2 seconds, we get the 1. And after 2.5 seconds, we unsubscribe, and that observable is done, and the memory leak is avoided. Now that we have some streams, we can manipulate them. And this is really where the power of RxJS comes in. So I'm going to start with my interval, again, 0, 1, 2, 3, 4, 5. But now I can do things with that. I can pipe on that observable and combine a couple operators. In this case, I'm going to filter on them. So I only want the things to survive that have a value less than 6. So instead of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's 0, 1, 2, 3, 4, 5, and I'm done. Note, done here means that's all I see, not that the observable has been unsubscribed. So I still have a memory leak. I still haven't cleaned it up, but I'm just not seeing anything more. And after the filter, I can map. And with map, it'll take a value and replace it with whatever gets returned from that function. So that 0, 1, 2, 3, 4, 5, in this case, gets squared. So now I have 0, 1, 4, 9, 16, 25, and I'm done. Few interesting notes about this. One is order matters. If I flipped these, we would do the map first. So we'd square, and then we would apply the filter, and only 0, 1, and 4 would survive, because 9 is too big. 3 is small enough, but 9 is too big. So the order you put these in here matters. Another interesting thing is you might recognize filter and map from arrays. These are pretty similar to array functions, except instead of operating on one at a time in memory or space, we're operating them one at a time in time. But you might look at this and say, this API is kind of weird that we have to pipe on it. With arrays, we could just do array.filter.map. RxJS used to be like that, but they had a lot of trouble with tree shaking, so they went to this pipe approach. Native observables with that WICG standardization work the way you would expect it. So a native observable would be interval.filter.map, because since it's native, they can do things that RxJS just can't do from the outside. And again, these are just two of many, many different operators that you can use to manipulate your streams. Some of the most important operators are called higher order operators. So imagine this is what we want. All right, we have our interval every second 0, 1, 2, 3, 4, 5, but we want to restart it every 4.5 seconds. So we want 0, 1, 2, 3, start over, 0, 1, 2, 3, start over, 0, 1, 2, 3. And what I have here might be the way you think to try this at the beginning. I'll have an outer interval that works every 4.5 seconds, and then I'll replace each of those values that get emitted with another interval of every second. And then I'll get my 0, 1, 2, 3, and I'll have a new interval and a 0, 1, 2, 3. And that would be great. And will it work? Not at all. The reason it doesn't work is map replaces the number with what is returned by the function, and what's returned by the interval function is an observable. Not the contents of the observable, but the observable itself. So this isn't quite right. Map is not what we want for this purpose. And a lot of people will look at this initially and say, oh, okay, I subscribed on the outside. The solution is to resubscribe on the inside. And anytime you see yourself doing a nested subscription, you're creating a code smell. That's not the approach to do, because you end up having to deal with all of these nested subscriptions, and it gets hard and it's easy to mess things up. Fortunately, RxJS has given us alternatives. In this case, merge map. Merge map is a higher order operator that does a flattening for us. So instead of just getting the observable to put on the screen, we get the numbers. So do we have what I wanted? Not exactly. It's closer. I get 0, 1, 2, 3, 4, 0, 5, 1, 6. And later on, 6, 1, or 6, 11, 7, 2, 7. The problem here is, yes, I am now creating a new observable every 4.5 seconds that's starting a new set of values, but I'm not killing the old ones. Sometimes merge map is exactly what we want, but it's not what I contrived. So what we want instead is something called switch map. Switch map adds to merge map by saying, all right, when a new value comes in, unsubscribe from the old one. So we get 0, 1, 2, 3. Oh, there's a new observable. Kill the old one, switch to the new one. 0, 1, 2, 3. There's a new one. Cancel, switch. 0, 1, 2, 3, cancel, switch. And this gives us what I said I wanted. And this topic could be a whole conference talk itself. I just gave higher order operators a really quick introduction. If you want to see another thing about it, I recommend this video. It's a 20-minute humorous skit about switch map at an Angular conference a few years ago. I really recommend it. So I've touched on a few of the operators. There are many of them. These operators are the power of RxJS, but they're also the confusion. There's over 100 of them, and they can be overwhelming. Fortunately, there's a lot of guides to help you. If you're a type of person who really wants to read and understand what's going on, the link there that says text will give you all the information you need. But if you're more of a visual person, RxMarbles is great. It will show marbles on the screen that will show with switch map, this one marble turns into these marbles, and then this one turns into these. And as I can move this marble in time and see that it'll cause cancellations and how things will get affected over time. It's really helpful to learn some of these things. But sometimes you don't know which operator you want, and so you can use the operator decision tree, or I call it choose your own adventure. So you can start out saying, all right, I want to start with 2 observables, and I want to combine them somehow so that once they've both emitted, then every time they emit, I can get some combination of the 2 of them. And that will let you do it. I want to create operator, click. I want to start with multiple observables, click. I want it to behave this way, click, 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 until it tells you, all right, what you use in this case is combine latest. And then you can go to the other links and say, all right, what on earth is combine latest? But even with that help, the number of operators can be overwhelming. I really like the link at the bottom here. It's an article from a few years ago that suggests there's 7 operators that if you start with those, they can help you solve 90% of your problems. Maybe not as efficiently as one of the specialized operators would be, but you can build your confidence and your skills with those 7, solve a lot of your problems, and once you understand the patterns, expand from there. So in summary, we have asynchronous reactive programming that handles 0 to many values. It's inherently cancelable, and it's important to cancel. And there are some operators that help you with cancellation that I haven't talked about yet, like take and take until. It's not as standardized as promises, but they're working on it. And it has a really powerful operator library in RxJS. And you might think that RxJS doesn't like the competition, that they're the de facto standard and this new standard coming in is going to take away their lunch. That's not true. They're actually really excited about it. You can read this post. They want to get out of the observable business and just be focused on the operator business. So they're quite happy to have native observables coming. And I only talked a little bit about native observables. If you want to know more, I recommend this talk by my friend and fellow Angular GDE, Rainer Hanekamp. And with that, it's time to talk about signals. So what are signals? Signals are a box that hold a value and notify consumers when value changes. So like a box or a cell that has a value in it, and it knows how to tell people, hey, my value has changed. Signals know nothing whatsoever about time. If you need to deal with time, that's what the asynchronous operators, primitives are for. But signals are just this simple concept of a box with a value. But it's kind of surprising how much cool stuff we can get from that. Now, I gave this matrix before, and this matrix is pretty full. Where in here will signals fit? The answer is they don't. I asked myself the wrong question. They're a completely different thing that solve a different problem. The problem they solve is state management. How do we get things on the screen to represent our state without being too hard to develop or being too slow? And the historical analogy I like to use to think about this is early gaming program. With the early games, like the first time that we'd have a terminal that would be, separate away, VAX systems, people with gray hair like me know what I'm talking about. The way that those were implemented was that, all right, there's a visual change on the screen. Here's the big screen, and our little character is going from here to here. All right, we'll send all of the information about the entire screen to the front end because that's easy to code. And it was easy to code. That incremental mode with full screen re-render definitely was easy to code, but it was slow because computers at the time were slow, networks were slow, and we're sending 20 times as much data for each screen than we need to. If we're only changing this little bit here, why are we sending the whole screen? So then they came up with retained mode or incremental re-render, which means, all right, this whole screen, we're only changing this little bit. We'll send the size of the part that changes and what the change is. And that's the little bit that we send. And then on the front end, it says, oh, I can keep 90% of it the same, and I only need to change this little bit. And it was a lot faster, but it was harder to code because we had to figure out where did the changes happen, and how do we cut that out, and how do we merge them back together on the client. Our goal as developers now with our screens is to figure out how to get things on the screen quickly. We want to get immediate mode behavior as developers to be easy, but get retained mode performance. And that's what signals give us. So here's a simple calculation that I like to use to help think about signals. It doesn't need signals yet. I'll come back to it later. So imagine we're scheduling a party, a wedding, or something, who knows. We're going to have 50 guests. We want to figure out how much it's going to cost to reserve the room. And it turns out that this venue has an approach to pricing that if you have less than 60 people, it's one price, and if you have more, they give you a discount. All right, so we can figure out our cost per guest. 50 is less than 60, so our cost per guest is 30. To get our total cost, it's 50 times 30, so we get 1,500. We've done our calculation, and it's easy. We're back to synchronous programming. But what if we remember, oh wait, every single one of our guests has a +1. We have 100 guests. Now, if this is just a function by itself, we can just call the function passing in the new value. But what if we have all of these values, the intermediate values on the screen? How do we know which ones to recalculate? How do we know when to recalculate? How do we know the order of calculation? Like, something changed. How do we recalculate only the parts that need to recalculate? And more interestingly, how do we make sure that we do it in the right order? We might naively, accidentally say, oh, I have a new num guests. I already know half the information that total needs, so I'll just recalculate it, and we're at 3,000. And then on another cycle later say, oh wait, never mind, our cost per guest has changed. So we need to recalculate total and show the new value. And so we'll show a wrong value as an intermediate value before we show the right value, and that's called a glitch, and users hate it, and we don't want that. And we've actually all used systems that have solved this problem. Spreadsheets. Now, I'm not claiming spreadsheets use signals. I don't know how they're implemented on the inside. But you can think about the problems that we're trying to solve by looking at a spreadsheet. This is a more involved version of the calculation I just showed. We have a total cost at the bottom, and again, there's a cost per guest and a number of guests, but there's also discounts and taxes and stuff like that. And you can see when we make our change to any of the inputs, we recalculate immediately to get the right answer, but only the cells that need to change. And we don't get any glitches. All of them recalculate exactly right immediately, and we don't have to do multiple calculations. When I make a change, it calculates it and it leaves it. It doesn't recalculate unless it needs to. This is what we want from signals. This is what we get from signals. So this problem of state management getting into the screen is a common problem for a lot of our frameworks. And so a lot of frameworks have actually converged on signals or something really close to signals over time. So here's a big list of frameworks that have all converged to signals or something signal-like over time. It's kind of like biological evolution. If you look at this picture of crabs, you'd think they'd all have a common recent ancestor, but they don't. They came from very different forms, but it just happens that having 6 legs and 2 claws is really a good way to live on the bottom of the ocean, so there's been convergent evolution. Same thing with signals. It fits the problem well, so there's been convergent evolution. So what's the big player that's missing here on this list of frameworks? React. Yeah, React went with hooks, a completely different approach, completely valid approach. Not saying anything wrong about it, but most of the other frameworks have gone for signals. And I'm not going to go through the history of this, but the first framework that pulled it all together and had it working under the name signals was called Solid.js. And you probably haven't heard of it. I mean, this came out in the era of yet another JavaScript framework, and this is a framework by a guy named Ryan Carniato. Apparently a really nice guy. You can read his blog post at the bottom to get more history than I have time to go into. But when just one guy comes up with a new framework, people don't really pay much attention to it. But then Angular grabbed it. And Angular isn't the biggest player on the scene by any means, but it's big enough that a lot of people paid attention when Angular jumped on signals. And you might wonder what this blue W logo is. It's for another Google framework called Wiz. It's an internal framework. So Angular is their external framework that has really good developer experience. Wiz is their internal framework that is focused on speed and performance. And a while ago, Google decided to converge these two frameworks that they have to share things like signals. So Angular gets the benefit of the same performance that is driving Gmail, YouTube, Maps, things like that. So if you are an Angular developer and you're using signals, you're using the exact same high performance things that make YouTube, et cetera, work well for you. Now, with this convergent evolution from a whole bunch of different frameworks, you might be worried about, are they going to be the same at all? There's an effort that's in the very early stages to standardize. You can read more about it. That takes an approach. The approach that they're taking is that they will write the actual primitives, and then all the frameworks will be able to keep their implementation. So if you like doing things in the Angular way or the Preact way or the whatever way, you can keep that way because the actual API and syntax will stay the same, but they will share an implementation. But this is really early, so it's not quite there yet. Now that was a lot of hand waving. Let's start looking at some code. And I'm going to start with some kind of pseudocode that is based on that standardized syntax. And we're back to our room rental calculation. So again, we're going to start with our number of guests, but instead of just starting with 50, we're going to wrap it in a signal. So we have this new signal of .state of 50, and now we have a box or a cell that has a value. We want to calculate our cost per guest, which is dependent on the number of guests. So that gets a callback. We're going to do a computed or derived signal that takes the value out of num guests, does the comparison, and now that box has a value of 30 in it. And we calculate our total with another callback. We'll get 50 out of num guests and 30 out of cost per guest. And so now total contains 1,500. And the effect is part of the API that says, all right, whenever anything changes, show the value, including the first value. So we're going to console log the value out, and we'll get our 1,500. Same as before, but a little bit of wrapping it with callbacks and stuff. But now we change the number of guests to 100. And this is where things get interesting. Signals use an approach called push dirtiness pull value. So when we change the value of num guests, it says, all right, num guests, you have a new value and you're dirty. So num guests broadcasts anything that pays attention to me, you're dirty too. So now cost per guest is dirty and total is dirty. And total will now tell effect, I'm dirty. And effect will say, I need to know your new value, calculate it. So we've pushed dirtiness down to something that wants to show the value, and now we're going to calculate the value up. So now total is going to say, I need to re-execute in order to get my value to not be dirty. I need to get a value out of num guests. Oh, that's a simple value. Good, I got that. I need to get a value out of cost per guest. Oh, that's dirty. Hey, cost per guest, calculate yourself. It's going to get the value from num guests, calculate itself, give the value to total, which will give the value to effect, so we see it on the screen. We pushed dirtiness down, we pulled the value up, we had dependency order tracking, so we only calculated things once. Everything that needed to be calculated was recalculated. Nothing that didn't need to be recalculated was calculated, and we got the first value, or the value correct on the first time without a glitch. That's what signals give us. And now, as an Angular guy, I'm going to show you how this works in Angular for a more realistic example. This is a small application or small component for a clubhouse that has a welcome message if the door is open and a button to open or close the door. The only independent state in here is whether the door is open. The syntax is a little different than what I showed on the previous slide. We're going to create this signal by using signal wrapping true, and now door open is a box with a value of true. Button text is there. It's a derived signal. We want to show either closed door or open door. And when that gets called, it's going to execute this callback and say, all right, get the value out of door open. In this case, that value is true, so we'll say closed door. So what's going to happen to the template is the template's going to come through and it'll hit the first line and say, if the door open, with parentheses, to get the value out, show the app welcome. So it's true. The value in that box is true, so we show app welcome. And then it'll come down to the button and want to show that. It needs to show the button text. It'll ask button text. Button text will calculate, like I just explained, and it will show closed door. But the interesting thing happens when someone clicks that button. It's going to execute toggle door, and Angular has a utility called update that will give the previous value and then update to whatever is returned. In this case, we negate it, so we convert the true to false and put it right back in. And now, door open is dirty. So because door open is dirty, it tells the template, the Angular template, hey, that first line in here is dirty. It also tells button text, you're dirty, and button text tells the template, line 6 or whatever it is, this is dirty too. The Angular template says, all right, this template is dirty. These specific lines are dirty. I need to re-render this. I don't need to do the old Angular zones way of checking the entire application. I know these individual lines are dirty. Re-render those. Dirtiness is pushed down. Now we're going to get the value up. Hey, what's the value of door open now? Get the value out. That's simple. The door is closed, so we don't show app welcome. Hey, button text, what's your value? It re-executes that callback, and now it says open door, and it displays that, and nothing's dirty anymore. We push dirtiness down, we pulled the value up, and we now have code that's not exactly as easy as if we didn't have any of this, but it's not bad at all, and we're getting really good performance. So how does Signals help the developer experience? There's no risk of memory leaks like we get with subscriptions. One-way data flow, memoization, and glitch-free. We get the right value. So which one should we use? You both it. We use it all. Because they solve different problems. As Ben Lesh from the ArcGIS team says, Signals for state, observables for events is pretty simple. The opposite is silly bad. Divide your labor. Use your observables, or sometimes promises, for your events and signals for your state. And in practice, what this means is back end will be observables, and anything that deals with time on the front is observables, and state management is signals. So we're going to have to bridge the gap somewhere. The initial way in Angular we got were these conversion functions. We can get to signal and to observable. So like imagine we had a situation where we had a selected ID that's a signal that contains a book ID number, and now that we know a book ID, we want to make a call to the backend to get more details about it. Well, that call to the backend, Signals can't do that. Observables do that. So we convert that signal to an observable, and then that observable can do our switch map and all the stuff on the backend, and we can convert it to a signal to display it on the screen. So they each handle their areas of specialty. This manual conversion is a bit ugly. Angular has given us a resource API where, again, we can start with that signal, and it gets wrapped in a resource where it gets given automatically to the stream, and internally the resource does the switch map for us, and then gives us actually a bunch of signals at the end, like loading indicators and error state and stuff like that. So I've talked mostly about promises and signals here, or sorry, observables and signals here, but remember, promises still have a niche. Going back to this matrix, I do see people say, I never use promises anymore because observables are more powerful, so why would I bother? And to me, that sounds like saying, I never use variables anymore because I have arrays and they're more powerful, so why would I bother? But we don't act that way. We don't wrap every variable in an array just because there's array things we could do to it. Still, promises have a niche, and they are the right thing to do with fetch. It really is the ideal use case. So in summary, promises and observables are both asynchronous. They deal with time. Signals are synchronous. Promises are a single value. Observables are 0 to many values. And signals are one value at a time. Promises are native. Observables are working on it. Signals are further away. Promises have cancellation sometimes with a friend. It's built-in and important for observables, and signals just don't need it. The main utility for promises is async await. For observables, there's hundreds of operators that you can use, and signals, it's really going to depend on your implementation. And the niche for promises is HTTP calls. For observables, it's event streams, WebSockets, anything like that. And for signals, it's reactive state and state management to get things on your screen. And I hope that helps you understand the difference between these primitives and when to use them. So my social's at the top. There's all the slides, and thank you.